Hey guys, my name's Zach, and this is 7.3 question number 7. We're evaluating the definite integral from 0 to a of dx over a squared plus x squared to the 3/2 power, while a is greater than 0. So the first thing we got to realize is that a squared plus x squared is going to need to be changed to tan squared x plus 1 equals secant squared x. So we're going to let x equal to tan of theta with the a, and dx equal a secant squared theta d theta. And once we do this, we also need to change the range of values. So when x equals 0, theta will need to be 0. And when x equals a, theta will need to equal pi over 4, because tan of pi over 4 equals 1, and therefore x will equal a. And so now we could change this integral from 0 to pi over 4, and then we're going to change dx to a secant squared theta d theta over a squared, and I'm just going to square this right now. It's going to be a squared tangent squared theta. And then what we can do is take out the a squared. So from pi over 4, or 0 to pi over 4, we got a secant squared theta d theta, and then we take the a squared out. It's going to be 1 plus tangent squared theta to the 3/2 power. Can't forget the 3/2. And then after that, we can substitute this right here for secant squared x. So we're going to have a secant squared theta d theta with a squared secant squared theta to the 3 over 2. And now we can take out or simplify the denominator. So we're going to have 0 to pi over 4, a secant squared theta d theta over a to the 3rd secant to the 3rd theta. And now we could take out these constants right here. So it's going to be pi over 4, 1 over a squared. And then we just have secant squared theta over secant 3 theta. So that will be 1 over secant theta d theta. And then you could also change this into cosine theta d theta with 1 over a squared. And we know the integral of cosine theta d theta is sine theta. So we're just going to evaluate 0 to pi over 4 sine of theta. And therefore, sine of pi over 4 will equal radical 2 over 2, and sine of 0 would be 0, so you don't subtract anything, and you can't forget this 1 over a squared, so we're just going to implement that, and the final answer is radical 2 over 2a squared.